Geometry of 2D shapes, triangles. Now you know now that I'm the dragon lady and this is one of my dragons helping me. We're going to solve problems in triangles. So this is Zing. I don't know how she related to the other dragons, don't ask me. So we are in flat land. All our shapes are flat. And of course the triangles think that they are very special. So let us meet the simplest form of a polygon. And if you put these triangles together, it can later form a beautiful three-dimensional structure. Here are the key questions. What is a triangle? How do we classify triangles? What are the properties of triangles? And then how do we use all of this to solve problems in triangles? So what is a triangle? Well, we know it's a polygon with 3 sides, 3 angles, and 3 vertices. Do you still remember what a vertex is? When 2 lines meet, that point is a vertex. How do we classify triangles? In other words, there are names for different types of triangles. Well, we classify triangles according to their angles and their sides. According to their angles, we first get the acute triangle. There are 3 acute angles. Do you still remember what an acute angle is? It's an angle less than 90 degrees. So this means angle A is less than 90 degrees, angle B and angle C. Note the notation. You need a caps on the A to show that it's an angle. An obtuse triangle. There's one angle that is obtuse. Do you still remember what an obtuse angle is? It's an angle between 90 degrees and 180 degrees. This means angle A is bigger than 90 degrees, and note that angle B and C must then be smaller than 90 degrees. A right triangle. One angle is a right angle. Do you still remember what a right angle is? It's an angle that is 90 degrees, and we show it by using a little square. So angle A is less than 90 degrees and angle B must be less than 90 degrees. Angle C is exactly 90 degrees. And we call this side that is opposite the 90 degree angle in a right triangle the hypotenuse. We're going to use the hypotenuse in later lessons. So let's look at the sides of triangles. An equilateral triangle. Equilateral. All 3 sides are of the same length. And we use these little lines to show this. This means line segment AB 6 centimeters, BC 6 centimeters, and AC, for example, is 6 centimeters. Which then implies that angle A, angle B, and angle C, all of those angles must be 60 degrees. A scalene triangle. All 3 sides are of different lengths, and that's why we use this notation. So, for example, AB is 8 centimeters, BC 7 centimeters, and AC 6 centimeters. An isosceles triangle. 2 sides of the same length. Now, if you want to get to know isosceles, say it fast. Isosceles, isosceles, isosceles. Note that the angles opposite those equal sides are always equal. So, for example, line segment AB is 7 centimeters, and BC is 4 centimeters, and AC is 7 centimeters. This means that angle B is equal to angle C. It's useful to summarize it on one page using different colors. Now you have to ask yourself the question, can an acute triangle also be an equilateral triangle? Make sure you know all these properties very well, because then it's so easy to solve puzzles in triangles. Happy learning!